Okay, so hello. This is a wee video about getting lsdtopotools to work in a Linux environment. I'm going to use the command line interface. So you're going to run lsdtopotools from a terminal window. For this example, I'm running it on our Linux servers here at the University of Edinburgh. So you will need to have a kind of Linux terminal environment running if you want to replicate this. So if you're not at the University of Edinburgh, you can do that using a Mac OS terminal window, or just in a Linux operating system, or using the Windows Linux subsystem if you're on a Windows machine. And the only real prerequisite here is you will need conda installed, and you also need to have the gdal command line tools installed. So at the University of Edinburgh, we've got those some of those programs installed on our servers, actually both of them. But I'm going to start out by showing you a terminal window. I use a program called MOBA Xterm to get my terminal windows. It's kind of a convenient program for that. And the first thing I do to get set up, so at the University of Edinburgh, our servers have lsdtopotools, but it's a slightly older version at present. So what I do to begin is I just start conda. I make an environment, and I've done this before. I started this video because it takes a little while. So I just use this particular command, which says conda create. I make a new environment, which I'm calling lsdtt_clt for command line tools. I want to install that from CondaForge, and I just install lsdtopotools. So it takes a little while for that to install, but once it's done, you go all the way down to the bottom here. It takes a little while. It's done a bunch of stuff. Then I activate that environment. So it says I'm now in this environment, and I can call one of the command line tools with a -v call, and that tells me what version I'm using. And right now I'm using version 0.9. It turns out on the Edinburgh servers right now, it's got 0.4. That should be updated soon, but if you want to get the latest version, just make a conda environment for lsdtopotools, and you can get the latest version. Okay, so what do we do with this once we've got it? Well, we're going to process some topographic data. The most common use case is to get topographic data from OpenTopography, so I'm going to do that. But before I do that, I need to go to the place where that data is going to be. So I'm just going to navigate the right folder. And this goes through my own directory paths. So you just need to know where your data is. So I've made a folder called San Jacinto, which is a mountain range close to where I grew up. So I'm going to download the data from there. If I go on to OpenTopography, I can get some data. So I'm going to go onto the data thing. Actually, I'm going to get global data, some Copernicus data. So let's go to the Copernicus one. I want to click on the 30-meter data. Then I'm going to select a region. So the San Jacinto Mountains are over here, close to the beautiful city of Riverside. And I'm going to just pick a little area around here. Okay, so this is the place I want. Yeah, get a geotiff of that. All good, all good. SJ. I think this will work without me sending an email. Okay. Right. So I just wait a few minutes here. And eventually I'll get a zip file that I can download. So you can all wait while I watch this. Oh, that's very fast. So I just grabbed this. this will go into my downloads. So I will go there. I will extract this, get it into the San Jacinto directory. I'm getting rid of this one because that's only there because I've done this before, right? So I have this tar.gzip file. I'm actually going to need to unzip that first. So let's go back over here. I can see what I've got here by using the ls command. It's much easier to unzip this stuff in Linux than it is in, say, a Windows environment. In Linux, there's a little tool called tar, and you can unzip with that. The flags you need are xzf. I just have done this so many times, I remember that. Oops. If you're wondering what's happening here, it's Linux, so if I just type the first few letters of what I'm doing, I can hit tab and it autocompletes. So I just do that, and it will have unzipped that. I get output _ cop30.tiff. Now, lsdtopotools, it doesn't read TIFF files. That's because, well, historic reasons. So it reads a different file type. It reads an nvbil file. We need to change the this TIFF into an nvbil file, and for that, we're going to use gdal. So gdal is also a series of command line tools like lsdtopotools, and it allows you to do a bunch of raster manipulation. I use gdal all the time, but I actually sort of haven't memorized all the commands. I just use my own documentation that I wrote my very own self to convert this. So where do you find that documentation? If you go into the lsdtopotools documentation, here's the website, and you scroll down to Introduction to Geospatial Data, there's a section on gdal. So basically, we use gdal warp for this. And this is the kind of data format, but I'm going to make a couple of changes here. So go back into my server. So I want to gdal warp this. So one thing I need to get the right UTM zone. So we use a UTM zone. California, I just happen to know, is zone 10 and 11. This is a little bit to the east. I'm not even going to check. I think this is zone 11, so I'm just going to use that. Hopefully that's the right one. Okay, next one, I need the input file. Okay, I need the output to be NV. So I do -OF for output format and type NV for nvbil. Now there's one or two other things you can do here. You can have the resampling method, and you can have the change the grid resolution. So even though Copernicus 30 is a 30-meter DEM, it's not really 30 meter. It's in decimal degrees, the grid spacing. So if it's not at the equator, it's not quite 30 degrees. So just remember, I'll go in here to figure out how to change the grid spacing, and it's TR is the way you change the grid spacing. So I'll do that. So -TR 3030. And if you change the grid spacing, you need to change the resampling method. So with R, the default is nearest neighbors. If you do default nearest neighbors, you will get this kind of striping effect in your DEM. Do not do that. I will use cubic resampling. You could also use bilinear. And I'm just going to call this new file sj.bil. So bil is the format of NV. There's also an ARC version of the bil file. You don't want that one. You want the NV bil file. So OF NV. Okay. If you're in the southern hemisphere, you need to tell it you're in the south. So there's a plus south, write that here, but we're in the northern hemisphere. That's the default. Okay, I just hit enter and it will process. And we have a bil file here. Okay, now what do? We want to use lsdtopotools. So lsdtopotools it interfaces with some files so there, I call them driver files, and those files are the instructions for what the topotools analysis does. And it's got keywords. So you can get all the list of the keywords by just doing calling one of the lsdtopotools command line tools. So the one with the most stuff in it and the basic stuff is lsdtt basic metrics, and you just type -h for help. Okay, if you want to see what has happened there, so let's go into this folder. So if I do -h, it ends up with both a CSV file and a HTML README file. If I click on that, you get this thing which tells you all sorts of stuff about how it works, and it also gives you all the parameter names that you can use. So it has the kind of full range of stuff you can do with this software. So I'm not going to read through all the stuff. You can do a whole bunch. One thing that you need to put in is the path and the file names. So so what I'm going to do, I'm going to go into Notepad. So if you do write path, that will give you the directory where your data is in. It turns out if you're just doing it in the directory where you're in at the moment, it will assume that's the right directory. So you don't actually need this. You do need the read fname. So that is the prefix of the file that you're working on. And the file that we're working on is SJ. Okay. So the next thing we want to do is we want to write a hillshade. True. Okay, I'm just going to double check if it's write or print. I always forget this all the time, even though I wrote the software. So let's go down here. Is it write hillshade? It is. Okay. So let's just look at that right now. Write hillshade true. Okay, so we're going to save this file, save as. Actually, I need to make sure that there's a space at the end. So save as, and I will put this where I had it. San Jacinto. I'm going to do this as all files, and I'll do sj.driver. Save. Okay, lsdttt basic metrics, sj.driver. Okay, slight edit. I needed to correct the thing. I got the wording wrong. It had write hillshade instead of hillshade. So I've just fixed that. And I've run this now. So I ran it with lsdttt basic metrics. And if I look up now, I've got this hillshade. Okay. So let's have a look. Just refresh this, and you end up. So this is what the raster looks like. Here's what the hillshade looks like. So here we go. We've got some channels, or sorry, we've got a hillshade. So that should basically get you started. But actually, another thing to look at is because we projected this, you get kind of slight distortion around the edge. So, so I've got this kind of awkward edge effect here, but let's get rid of that. Remove the layer. Remove the layer. No, don't rename, remove it. Okay, another thing that you can do is remove C's, which the effect of that is to get rid of data that is, so it turns everything below 0 into no data. The reason why this works on these little edge effects is because the default no data is -9999, but gdal doesn't really do that very well. So I have written this remove C's thing to kind of fix that no data issue. So let's just run this again. Run it again. Okay. And let's have a look at the output. So refresh. So now you don't have that same little edge effect that you had before. So you can see this, there's this one pixel that gets removed because of the projection, and now that's no data instead of some black strip. Okay, so hopefully this has been useful, and you can get started with the command line tools of lsdtopotools now.